Once again, very good day to everybody. This is Technological Innovation in New Media, and in this class, we discuss about the IEEE 802.11e standard, especially E standard. Actually, 11 is the exact standard, and E is the version. Okay, and then we discuss about IEEE 802.16. Okay, so this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session, to share my knowledge among my fellow national, international participants, students, and young researchers. Right. So in this class, we will have a short introduction towards IEEE 802.11. Then we discuss about the media access control frame, about the FC frame control, then specifically about IEEE 802.11e. Then we have the standards that are associated. Then we discuss about EDCA, Enhanced Distributed Channel Access. Then in the second part of today's class, we discuss about the max value, Ymax, okay, IEEE 802.16, orthogonal frequency division multiplexing, and multiple input, multiple output. Then we discuss about IEEE 802.16D standard, which is nothing but data security layer replacement, and of course the competition. So I've already given the independent work for you. Please go through them. Please complete them at your best available time. And at regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. Right. So this is IEEE 802.11. We are having like control medium access, especially for roaming, authentication, security, privacy. In order to conserve the power that is consumed, you can go with the MAC layer. So you can use the best possible services with the asynchronous data service, and of course the optional time bound service. You can use them and you need not have to use them also. Okay. So IEEE 802.11 has two max layers. One is DCF and another one is PCF. DCF is distributed coordination function. So maybe it will use carrier sense multiple access collision avoidance technique as access method, as the wireless LAN cannot implement the carrier sense multiple access and collision detection. Okay, so it will be offering asynchronous services. And then PCF point coordination function, it will be implemented on the top of the distribution coordination function, and here it will be used especially for the time service transmission. So maybe for competition between two users or competition about multiple users, you can have a contention free polling access method and it is centralized. Okay, so this is the MAC frame that is associated. We will have FC frame control, duration, address 1, 2, 3. Okay, then we have SC, address, data, and cyclic redundancy check. So for each of them, we will have like frame control 2 bytes, duration ID 2 bytes, address 1 6 bytes, address 2 6 bytes, address 3 6 bytes, SC 2 bytes, address 4 6 bytes once again, data 2312 bytes up to, and cyclic redundancy check 4 bits. And similarly, protocol version 2 bits, type the 2 bits, subtype 4 bits, 2DS 1 bit, from DS 1 bit, more fragment 1 bit, retry which is 1 bit, power management 1 bit, more data or maybe extended version will have 1 bit, and WAP 1 bit and order 1 bit. So we'll have like several frames. Okay, we'll have 9 fields, and here we'll have this IEEE 802.11 MAC frame structure. Okay, so here in the FC or maybe frame control field, it is nothing but 2 bytes, and it is going to define the type of the frame or maybe some control information. So maybe we'll have the version like 2 bit. Okay, so it will be specifying the current protocol version. Okay, right now it is fixed for 0, and afterwards it will go on. Okay, and then we have the type. It is nothing but the function of the frame. So it is 2 bits, and maybe for management, control, or maybe data, you can have specific value. Okay, for management 00, control 01, data 10, and maybe value of 11 is actually reserved, like in the case of binary. Okay, and then we have the subtype. Okay, so it is the subtype of the frame, like it will have 0000. Okay, for the association request, and maybe 1000 for the beacon. Okay, and then 2DS. Okay, it is the destination frame. Okay, it is nothing but the especially for the distribution system, it is actually 1 bit long. And then from the distribution system. Okay, so it will be indicating that the frame is coming from the distribution system. Okay, so it is actually 1 bit long, and then there is more fragment also. So which means that when it is set to 1 means, which means that the frame is followed by other extended more fragments as well, and it is also 1 bit long. And then read write. For example, if the current frame is actually a retransmission of an earlier frame, this bit is actually set to 1. So it is a 1 bit long frame. And then we have power management. Okay, so it indicates the station after successful transmission. It is also 1 bit. So if you set it to 1 means it will be in the power save mode. You can go with the power management. And for example, if the field is set to 0 means the station will be in the active mode. And then more data. For example, the receiver has more data to send to the sender, which than the current frame. You can go with more data. So it is actually 1 bit long, and it can be also be used as an access point to indicate that the station is in the power save mode or active mode. Normally, for power management function, it will be in the power save mode. Okay, so that which means that more packets will be buffered, or it can be used by the station to indicate to a access point after being contended or maybe pulled. And then WEP, okay, it's a security mechanism, standard security mechanism for which IEEE 802.11 is being applied. We have also order also, so which means that you should maintain a very strict order. So the receive frames must be processed in a strict order, and that is for strict order it is set to 1. Okay, and the length is actually 1 bit. Okay, and duration is nothing but the time period during which the medium is actually occupied, so that you can specify in the microseconds. Okay, so the duration you can specify the length of the field to be 4 bytes. And then you'll have address 1 to 4. Okay, so whenever you say address means it is 6 bytes. Okay, so that contains the standard IEEE 802 MAC address. Okay, so 6 bytes means it's consuming like 48 bits. Okay, so the address depends on the destination, distribution system bits in the frame control field. Okay, and then you have SC, sequence control. So here the sequence number and the fragment number would be set. It is actually 16 bits. Okay, or maybe 2 bits. And you specify, for example, sequence number you can specify 12 bits, and fragment number you can specify 4 bits. And since the acknowledgement can be duplicated, which means that sequence number is used to filter the duplicate frames. And then data, it's a variable length field. It will be containing the information specific to the individual frames. Okay. Then you have CRC, cyclic redundancy check. So it will be performing the error correction, error detection scheme to ensure that the frame is free of error. Okay. So it is actually 32 bit. Okay, or maybe 4 bytes. So this is IEEE 802.11e, especially for the quality of service for the wireless LAN. You will be using this one. So here you are going to provide alterations to the media access control layer. So for streaming the video or maybe voice over internet protocol, you can use this IEEE 802.11e standard. Okay, so generally for Wi-Fi multimedia, you will be using this one, and of course with the high-speed internet access, okay, with the voice over IP, you can go with full motion video and then high quality audio also. Okay, so you'll have like different stations, 1 Mbps, 2 Mbps. Okay, so that is corresponding to this entry point to the classifier and across the network. So here we have DCF and PCF, okay, distributed coordination function and point coordination function. Then you will have contention based channel access, okay, hybrid coordination function across the areas. Okay, so here the networks which are using this 802.11e will be operating at frequencies between 2.4 and then 2.4835 gigahertz, or maybe at the higher limit it will go up to 5.75 to 5.85. okay, so like the frequency can be corresponding for more channels as well. Also we have faster data transfer speeds and of course less interference problem. So the standards, it is backward compatible, so that is the greatest advantage, because unlike the other protocols we have seen, it is not backward compatible with the DCF as well as PCF, and of course it is also supported by the HCF, hybrid coordination function. And then we also have enhanced distribution coordinated function also. So the stations which are operating under 802.11e, you call it as the enhanced stations, nothing but we will have the enhanced distributed coordination function. So it will be behaving like a centralized controller, okay, and for the other stations you can call it as a hybrid containers. So here it will be having a policing as well as deterministic channel access. Okay. So HCF, hybrid coordination function, will be providing guaranteed services definitely at higher probability. Okay. So here it will be using signaling protocol to actually go for admission control and specifies the service rate requirement. Okay. So these are the layers like a network layer, transport layer, session layer, presentation layer, application layer. Okay, so we'll be having the DCF, PCF corresponding to the data link layer, and of course in the physical layer you'll be having the versions 802.11, A, B, G, and N. So this is also a functionality of 802.11e. Okay, so for example, if you have high priority traffic, means definitely it has higher chance of being sent than the lower priority traffic. Okay, so which means that a station with higher priority traffic waits very less time, okay, before it sends a packet on an average than the low priority traffic. Okay, so you can accomplish by the traffic control media access protocol, okay, which is actually a variation of the CSMA, carrier sense multiple access collision avoidance, using the arbitration interframe space. Okay, so AIFS for the higher priority packets. Okay, so higher priority traffic, definitely it will wait lesser time than before sending, and definitely it is uh, it has to wait lesser than the lower priority traffic. Okay, and then enhanced distribution channel access provides contention free, which means that it is competition free access to the channel for a period called as the transmit opportunity. So transmit opportunity is nothing but the time interval during which the station can send as many frames as possible. So which means that it is the duration for which the transmission does not exceed the maximum duration. Okay. So which means that if the frame is actually very large, means it will be divided or maybe fragmented into small frames. So the use of the transmit opportunity will be reducing the problem of the low rate stations, and that definitely would be gaining a inordinate amount of the channel time. Okay. So here we will be having a transmit opportunity of 0, which means that it is limited to single MAC service data unit, MSDU, or maybe MAC management protocol data unit, MMPDU. And then we have WiMAX, which is nothing but 802.16, especially for the wireless broadband communication technology, and for high speed data you can use the WiMAX or IEEE 802.16. Okay, so whenever you say WiMAX, you should say the standard. Okay, so WiMAX is nothing but worldwide interoperability for microwave access. Okay, so that is the WiMAX. Okay, so it's a technology for point to multi-point, point to different point wireless networking. So you can install a new high-speed data network very cheaply without like cost and time required to install a wired network. So definitely a wireless network is having faster access. Okay, but definitely wired will have more solutions, will have high speed, but definitely with regards to installation features, definitely it will be taking much time. Okay, and the distance and cost involved is also less with the case of WiMAX. And generally for mobile applications for high speed data, you can use the WiMAX. Okay, so this is the thing. We'll have the line of sight backhaul and to the telco core network, okay, to the internet. Okay, and then we'll have the base station providing services across the roaming user and the wireless metropolitan area network. Okay. So WiMAX is a standard for wireless metropolitan area network that can be developed by the working group number 16 of 802.802. So we'll have point to multi-point broadband wireless access. So 802.16a was actually developed and then launched, and it was redefined. We'll have 802.16d, 802.16 2004 was actually released, and after that came 802.16e or maybe 802.16 2005. Okay, so especially for roaming as well as mobile networks, mobile markets, you can use the wireless metropolitan area network. Okay. And then we'll have orthogonal frequency division multiplexing, especially for providing high speed data without selecting fading. That is the reason you use OFDM. And then MIMO, as the name implies, multiple input, multiple output. For multipath propagation, you can use WiMAX. Okay, and for operation with low signal strength levels, if you have to allow higher data rates, means you can use the MIMO. So since the formation or maybe the understanding, several WiMAX applications has been developed, several versions has been developed, and definitely it is optimized for the suitable application. Okay. So here we will be having 802.16d, that is especially for the data security layer. So this you can call it to be 802.16 2004. So it is closer to the original version of WiMAX defined under 802.16a. Okay. So for providing a wireless equivalent or maybe for fixed applications, you can use the DSL standard, data security layer, often called as the WiMAX broadband. So this is the DSL replacement. So these are the standards based technology which enables last mile delivery for the wireless broadband access as an alternative to maybe cable and maybe data security layer. So maybe here you will have home users, will have businesses, and then mobility. So this is 802.16, 802.16e and 802.16a or maybe D. Okay. So this D is able to provide data rate up to 75 Mbps, and definitely for fixed DSL replacement you can use them. Okay. So it can also be considered as a backhaul, and definitely the cell radii, okay, can be up to 75 kilometers. And then we have the nomadic access. For fixed technology, definitely it works good, but definitely for higher standards for mobile, you should upgrade it. Okay, so it provides the ability to connect to the WiMAX for a variety of locations, and definitely you can use it for future enhancements. Like 802.16e, generally for the best effort services, it will be providing up to 15 Mbps, and cell radius you can have between 2 and 4 kilometers, especially for the mobile or maybe nomadic applications. And then competition, the competition definitely depends on the type or maybe the version. Okay, so we'll have DSL cable lines, especially for high speed data, and definitely on the downside it can also pose a problem to the DSL cable operators. Okay. So as a long-term evolution, LTE was being developed. Cell phone operators saw the mobile version of WiMAX, and definitely it was creating a problem. Okay. So it was even considered for adoption also, maybe because IMT 4G standard, but LTE long-term evolution was adopted as a standard. Leaving WiMAX, you can use it for fixed WiMAX broadband. Okay. So maybe for last mile delivery or maybe point-to-point applications, you can use the WiMAX. Other than that, LTE long-term evolution is better. So this is the minimum work 9 for you. Demonstrate IP over IEEE 802.16 networks across any medium. Please complete them at your Google Classroom, and I will be checking them as soon as possible.